Numerical on potentiometer. A cell in the secondary circuit. This is cell. This circuit is called secondary and this is called primary circuit, and this is a battery. This circuit is primary circuit and this is a secondary circuit. A cell in secondary circuit gives null deflection. This cell gives null deflection for 2.5. For 2.5 the length of the potentiometer having 10 meter length. See, when this cell is connected and we move this jack on this wire AB and this wire AB, at this point it gives, at this point, that is say J1, it gives balancing point. Balancing point means when we move the jack along the wire potentiometer wire AB, at some point this galvanometer will show no deflection, zero deflection, no deflection. That is called balancing point for the wire. And at this moment, when it is in balancing point, from the wire, jack is in balancing point, we have to note one thing, the potential difference. Potential difference of balancing point, balancing length. Say this length is, we say this length is L1. Balancing gives EMF of the cell. This is very important point. When it is balanced, this length, that length is from A to J1, gives this potential of this length gives the EMF of this cell, not this one. This is a battery. So E naught is equal to, what is E naught? E naught is equal to battery in primary circuit. Battery, and what is V? That is potential gradient. K is equal to potential gradient. What is potential gradient? Is equal to the EMF of this battery divided by the length AB. This length AB, where AB is equal to battery in the primary circuit, AB is equal to a length of potentiometer wire. Now, because there are two conditions given, we call this one as L1 first. So it means it is for L1, it gives at 2.5 meter, 5 meter length, it is giving a balancing length, and potential gradient K is equal to epsilon naught by AB, where AB is equal to, so we can say in the first case K 1, that is potential gradient 1 is equal to epsilon naught divided by AB. That is potential of the primary battery per unit length. That is AB, which is, we can write it as E naught by the length. What is the length? The length is equal to 10 centimeter. This length is equal to, 10 meter. Length AB is equal to 10 meter. So 10 meter, or we can simply write epsilon naught by 10. This is K1, and L1 is equal to 10 meter in the first condition. Null deflection, that is L1 is equal to 2.5 meter. This is the case 1, 2.5 meter. So with this now we can write. See, at the null point position, this potential drop across this wire gives the EMF of the cell. This we have already seen from the principles of potentiometer. In that case, we can write the EMF of the battery, which is EMF of the battery is equal to potential of this one, that is potential V A J1, which is equal to K1, which is K1 into L1, K into L1, because potential as it is K is equal to battery EMF is equal to VA1, K is equal to this we can write epsilon naught by AB in this case is 10, that is K, we say K1, epsilon naught by 10. So epsilon, this is K1, what is K1 is equal to epsilon naught by 10. Epsilon naught by 10 into 2.5, because epsilon naught, see this is equal to K into L1, which is equal to K1 into L1, because first case epsilon naught by 10 into L is equal to 2.5 in the first case. In that case we can write the EMF of the cell is equal to epsilon naught, this we divide 1 by 4, 2.5 divide this one is equal to epsilon naught by 4. This we can write the equation 1. So after meter having 10 meter length of wire. Second condition, if the length of the wire is increased by 1 meter, now L2, this wire, see the situation like this, from A to B, the length of the wire is now increased by 1 meter. From B is shifted to here, we say B dash. So first L1 is equal to, what is the L1? The length initially is equal to 10 meter, and this is equal to epsilon naught by L1 is equal to epsilon naught by 10, and this is equal to K1 into L1. So we got the first equation, this is the first equation. Second equation, now the wire is increased, now we reproduce it here, we will write it here. This is earlier it was A, B, and at this point the same battery is connected through a galvanometer and the length is increased by 1 meter, that is earlier it is 10 meter, it is increased by 1 meter, and if the length of the wire is increased by 1 meter, it means L2 is equal to 10 plus 1 is equal to 11 meter. It means the length, only thing earlier this was AB, now it is increased by 1 meter. L1 is equal to 1 meter. 1 meter without changing the cell. It means cell is also same. E also same. This is cell and this is battery. Without changing the cell in the primary, it means E0 is same. Without changing the cell in the primary, the position of null deflection is now. What is the position of null deflection? See, position of null deflection means now we will find out in the second case K2. K2 is what? K2 is the potential gradient which is equal to the primary cell circuit into length. Length is equal to 10 plus 1. So this is equal to epsilon naught by 11, K2. Now K2 has changed, potential grade has changed. Earlier the potential gradient is epsilon naught by 10, now here epsilon naught by 11 because the length has been increased by 1 meter. So we can write in the second case, we can write epsilon naught is n, then K2, that is potential gradient in the second condition after increasing the length by 1 is equal to epsilon naught by 11. After increasing, now we move this. So after we move this to some balancing point. Say about first initially it was here J1 was here. Now we move this somewhere here, that we call it as J2. It means what? It means the length is increased from initial position to final position to 1 meter. Now again the battery, the jockey is moved on the wire AB. Now we are getting the null point here. Null point means no deflection here. no deflection here, and that length we call it as L2, that is J2 J2. So K2 is equal to epsilon naught by 11th, and now in this case already we have seen the potential difference of balancing length. This balancing length now gives the EMF of the cell, because this is not changed and this is not changed. Now only thing, the length is changed and the cell's EMF is not changed and battery EMF is not changed. Only thing, the length is changed. In that condition, this length gives the EMF of the same battery. That is, we can say EMF of the battery, of the cell is equal to, as it is, we have EMF of the cell is equal to VAJ2. This potential, EMF of the cell is equal to this length. Right, V into A J2. So K1, K2 we have found out epsilon naught by 11, and L, what is L2? L2, this we have to find out, this distance, because this L, this is capital L, this is small l. First condition, this is the L1, second condition, this is L2. L2 we have to find out what is the balancing length. After changing the length, what is this length we have to find out. So that we keep it as L2. So what is E? Epsilon naught E is equal to K2 into L2, because this potential difference between these 2 points or these 2 points, potential difference between these 2 points is equal to its potential grade into L2, and this point is equal to its potential difference into L1, K2 into L1. But the EMF remains same, is equal to, what is K2? K2 is equal to epsilon naught by 11 into L2. That is, we have to find out. So this is the second equation, which is equal to, this is the equation we have framed. Now we have framed this equation. Now see, you have to be very careful. Here this is not changed, this is not changed. Only the first case, this was the length, second case, this was the length, and first case, this is the balancing length, second case, this is the balancing length, and this potential is equal to K2 into L2. This potential is K1 into L1. This is what we have written, and which is equal to epsilon naught by 11 we have seen. So now we got the two equation, this equation and this equation we can compare now. We are comparing, we get the value of L2. See, E is equal to epsilon naught by 4 is equal to epsilon naught by 4, which is also equal to epsilon naught by 11 into L2. Epsilon naught into L, this we have reduced into, this is equal to epsilon naught by L1, which is equal to epsilon naught by 10 into 2.5. That is coming out to be this one. So now we have to compare this one, this and this we cancel, and L2, that is 1 by 4 is equal to L2 by 11, that is L2 is equal to 11 by 4. 11 by 4, it comes out to be 2 times, is equal to 2 points, that is 11 divided by 4, 8, and 3, 7, 28 into 2, 5, 2.75. Since the length is given in meter, it will be in meter. So L2, the balancing length, when it is changed to J2, see earlier it was in J1, now it is to J2, this length L2 is given by 2.75 meter, 2.75, it is L2 is equal to 2.75 meter. This is the answer for this question C. This is the right answer.